Hey folks, so this is section 4.4 and I would like to just do one example in this section. So if you would take your notes please and go down to example number 6. Let's take a look at that one. And this says that we're to graph by hand and we're to solve. And if you'll look a little bit down, there are 3 different things that we're supposed to be solving, a part A, a part B, and a part C. The first part of this is exactly the way that we are used to looking at. So notice that they were really nice to us. Not only did they give us the polynomial, but they've also factored for us. So they've done part of the work for us. We know by looking at the degree that the end behavior is going to be a 1 up, 1 down. Not only that, because the leading coefficient is positive, it's going to be overall going uphill. Secondly, the y-intercept is also very simple to find. Remember, you plug in 0 for all the x's. If you plug in 0 for all the x's, the only thing that's going to be left is a negative 30. So my y-intercept then will be the coordinate 0, negative 30. And then as far as bouncers and breakers, you remember that we're looking at multiplicities here, and as you look at the factored version, there are no repeat zeros. There's no repeat factors. They're all different factors. So in this particular case, we understand that all of my zeros are going to break through the x-axis. All right, so now before we head into parts A, B, and C, let's go ahead and just graph what we have. We know that we're going to have zeros at x equals 3. You see I have that marked over here on my graph. We have a 0 at x equals negative 2, and we have a 0 at x equals negative 5. And that's coming straight off of our factors. We also know our end behavior, so we're going to start down at the bottom, we're going to end up at the top. And so as I go through each one of my zeros, I'm breaking through the x-axis. I'll put my y-intercept in after I've drawn the rest of my graph. So let's head straight up to the negative 5, 0, break through the x-axis, then come back and break through the negative 2, 0, and then end up at the top, just like my end behavior tells me to. Wherever I ended up going through the x-axis, I'll call that the point negative 30. I'm not going to worry about making that one 30 blocks down or anything like that. So then this is a picture of my graph without ever having to put it into my calculator. All right, so let's go straight into part A. Part A is no different from all of the questions that we've already been doing. Where does my function equal 0? The English version of that, what are my x-intercepts? We already know what those are because we've already answered that question. So my x-intercepts, I have 3 of them, x equals 3, x equals negative 2, x equals negative 5. The next one, however, is a little bit different. Notice that it's asking, where is my function less than 0? Well, we know that equal to 0 is on the x-axis. Less than 0 is going to be anything below the x-axis. So we can write that down here. This is going to be, actually I think that this is already here. Yeah, this is negative, or it's below the x-axis. So when you look at your graph, you notice that you have this part right here is below the x-axis, and this piece right here is also below the x-axis. So how do I write all of the values in there? I'm going to use intervals. So my first interval will take me from negative infinity up to negative 5. Remember, only use x values. And then the next piece of my interval will be from negative 2 to positive 3. So from negative infinity to negative 5 and from negative 2 to positive 3. Notice I did not use square brackets here because I only wanted what was below the x-axis, not what was on the x-axis. If this had said, if this symbol here had been a less than or an equal to 0, then I would have wanted on the x-axis. But in this case, I only want below the x-axis. Now let's do the exact same thing for part C. Part C says that I want everything greater than 0, above the x-axis, or positive. So when I look at my graph, I have this piece right up in here that's above, and I also have this piece here that is above. So that first piece that is above, it starts at -5 and it ends at -2. The second piece starts at 3 and ends at positive infinity. Again, I did not use any square brackets here because I did not want the on parts of the graph. I only wanted above the x-axis, not on the x-axis.